Hello students, in the previous lecture we have taken key elements of the mechatronics. In this lecture we will take different levels of mechatronics and measurement characteristics. So first, levels of the mechatronics are also called as the evolution of mechatronics. So first level is a primary level that integrates electrical signaling with mechanical action at the basic control level. For example, fluid valves and relay switches. So basic components which are used in mechatronics are also known as a primary level. Then secondary level, it integrates microelectronics into electrically controlled devices, for example, cassette tape player. So it integrates microelectronics called as a secondary level. Then territory level or third level of mechatronics, in that it incorporates advanced control strategy using microelectronics, microprocessors, and other application specific integrated circuits. For example, microprocessor based electrical motor used for actuation purpose in robots. So this is called as a third level. Then next is a quaternary level or fourth level. This level attempts to improve smartness a step ahead by introducing intelligence. That is in fourth level all advanced systems are used, and in that we can take example of artificial neural network, fuzzy logic. That is also fault detection is there in the fourth level. If any fault occur, fault detection is important, and isolation and capability into the systems. So levels of mechatronic system integration. So we'll take other examples related to also. That is first level. In the first level, conveyors, rotary tables, auxiliary manipulators. That is all these are comes under mechanical components. But in electronics, if you use some basic components, then that level is called as first level or primary level. Then next is the secondary level. In that secondary level, operated power machines, that is turbines and generators, machine tools and industrial robots with numerical program management. So in secondary level, some numerical program management is also there. So next is the third level. Here in the third level or territory level, synthesis of new precise information and measuring high technologies gives a basis for designing and producing intellectual mechatronic models and systems. So in sometimes fourth and third level is mixed. That is in that some advanced technologies are used, and just as previous slides we have mentioned, that is fuzzy logic, neural networks. Then you can take additional, that is IoT you can add. So some advances in electronics and mechanical or all branches advances you can add in that mechatronic systems. Then in mechatronic system, as previously mentioned, there are n number of applications for MEMS, for consumer electronics, then in tools, in computers, then for cars, then stealth bomber for high speed trains. This mechatronic system is useful, and this figure we have previously studied, and in that, which is a combination of all, that is all branches, that is a multidisciplinary approach should be there, and all these are the applications. Then next, characteristics of the instruments. So in the mechatronics, n number of instruments are used, therefore measurement characteristics plays very important role in mechatronics. So there are two types of characteristics, that is a static characteristics and dynamic characteristics. So one by one we will take. First, static characteristics. Static characteristics of an instrument are required to be considered for the instrument which measure unvarying process conditions. Unvarying process conditions. The static characteristics are defined for the instrument which measure quantities which do not vary with time. So quantities which do not vary with time is called as static characteristics. Then main static characteristics are accuracy, sensitivity, reproducibility, drift, static error, dead zone, precision, threshold, linearity, stability, range or span. So these are the n number of static characteristics. Out of them in exam, 4 to 5 characteristics for 2 marks define measurement characteristics or give difference between any two characteristics or give difference between accuracy and precision. Such type of questions are asked. So first is the accuracy. It is the degree of closeness with which an instrument reading approaches the true value of the quantity being measured. Degree of closeness with which an instrument reading approaches the true value. The accuracy of a measurement indicates the nearness to the actual or true value of the quality. Then next is a precision. Precision, it is a measure of a reproducibility of the measurement that is given a fixed value of a variable. Precision is a measure of degree to which successive measurements differ from each other. So this is a accuracy and precision curve as shown in this figure. This is a actual target or reference value, and this is a accuracy, and this is a precision. So up to this and in between them this is a precision, and up to this point there is a accuracy. Then we'll give uh, or explain difference between accuracy and precision. So accuracy represents degree of correctness of the measured value with respect to true value, and precision represents degree of repeatability of several independent measurements of desired input at the same reference conditions is called as a precision. The next definition of accuracy. Accuracy, the next difference point is accuracy of instrument depends on systematic errors, where precision of instruments depends on factors that cause random or accidental errors. And next is a sensitivity. What is meant by sensitivity? So sensitivity is the ratio of change in output of an instrument to the change in input. So ratio of change in output of an instrument to the change in input. So change in output, change in input. These words are important. The manufacturers specify sensitivity as the ratio of magnitude of measured quantity to the magnitude of the response. The ratio is called as inverse sensitivity or deflection factor. Then another definition of sensitivity is given by, that is, a sensitivity of an instrument is the ratio of change produced in the instrument output to the change in the measured variable. So it is called as a sensitivity. Then next definition is a stability. So what is meant by stability? The ability of an instrument to retain its performance throughout its specified storage life and operating life is called as a stability. So this stability parameter is very important. So you can take example of any equipment, electronic equipment. In that equipment, the stability is a very important. That is this stability more concerned with the bathtub curve of the equipment. So what is bathtub curve? So this is called as a bathtub curve. So this is a structure like a bath, and from this bathtub curve, if we take the example of any mechatronics equipment or any electronic equipment, so at the starting of the equipment there is a failureness of the component of the equipment is there, and after some time there is a stable output. So this is a stable output, and after some time or some years, due to aging effect, there is a failureness in the equipment. So equipment fails or component fails. So this curve is called as a bathtub curve, and this middle portion is called as a stable output or stability, you can say. So the ability of an instrument to retain its performance throughout its specified storage life and operating life is called as a stability. Then reproducibility. The reproducibility is defined as degree of closeness by which a given value can be repeatedly measured. That is a reproducibility. Word itself explains the what is reproducibility. Is defined as degree of closeness by which a given value can be repeatedly measured. The reproducibility is specified for a period of a time. Perfect reproducibility signifies that the given readings that are taken for an input do not vary with time. So this is a definition of reproducibility. Then next is a drift. So what is meant by drift? The drift is defined as gradual shift in the indication over a period of a time where the input variable does not change. So this word is important. Input variables does not change. The drift is defined as gradual shift in the indication over a period of time where input variable does not change. Drift may be caused because of environmental factors like stray electric field, stray magnetic field, thermal EMFs, change in temperature, mechanical vibrations, etc. Drift is classified into three categories, that is a zero drift, span drift, or sensitivity drift, or zonal drift. So keep in mind these definitions. Drift. Then next is a static error. So what is meant by static error? It is the deviation from the true value of the measured variable. So this word is important, deviation from the true value of the measured variable. So in some equipments, standard values are specified. If there is an error, that is a deviation from true value, then it is called as a static error. It involves the comparison of an unknown quantity with an accepted standard quantity. The degree to which an instrument approaches to its expected value is expressed in terms of error of measurement. Error of measurement. Then next is a dead zone. Word itself indicates dead. That is a no output. You can say it is the largest change of input quantity for which there is no output. Largest change of input quantity for which there is will not get the output is called as dead zone. For example, the input that is applied to an instrument may not be sufficient to overcome friction. It will only respond when it overcomes the frictional forces. So consider this figure. So here we will not get the output called as a dead space or dead zone. Then next definition is a linearity. What is meant by linearity? Linearity is defined as ability of an instrument to reproduce its input linearly. Linearity is simply a measure of the maximum deviation of the calibration points from the ideal straight line. Linearity is defined as linearity is equal to maximum deviation of output from idealized straight line. Actual readings is called as a linearity. Then range or span. So range and span is also important parameter, a measurement parameter. So the minimum and maximum values of a quantity for which an instrument is designed to measure is called as a range or span. Sometimes the accuracy is specified in terms of range or span of an instrument. So what is range or span? Consider this example. Here thermometer is as shown in this figure, uh, and range of that thermometer is minus 20 degree to 60 degrees Celsius, and full scale reading as mentioned here, and it is called as a range or span. Beyond that 60 degrees Celsius we can't measure, and this is a minimum range, that is a minus 20 degrees Celsius they have mentioned. So span, this is a normally accepted as the input signal range that the measurement system will measure. Example as mentioned here, thermometers used by doctors have a span of ranging from 35 degrees Celsius to 42 degrees Celsius. Then bias, the constant error which exists over the full range of measurement of an instrument is called as a bias. Constant error continuously occur, that errors which exists over the full range of measurement. जितना भी आप measure कर रहे हैं उसमें there is a constant error occur, then it is called as a bias. Such a bias can be completely eliminated by calibration. The zero error is an example of bias which can be removed by calibration. So calibration of equipment is very important. So yearly 2 times you can do calibrations of each and every mechatronics equipment, also electronics equipment. So after calibration they will give the correct readings. So this calibration part is important. Then next is the tolerance. This word you have already studied, that is tolerance. It is the maximum allowable error that is specified in terms of certain value. While measurement, it is called as a tolerance. Maximum allowable error means uh, maximum allowable error. Beyond that, we can't allow the error. So maximum allowable error that is specified in terms of certain value. So if maximum allowable error is a 5 and it goes beyond that, we can't allow. So it is called as a tolerance. It specifies the maximum allowable deviation of a manufactured device from the mentioned value. And next term is a hysteresis. So what is hysteresis? Hysteresis is a phenomena which depicts different output effects while loading and uploading. Hysteresis takes place due to the fact that all the energy put into the stress parts when loading is not recoverable while unloading. When the input of an instrument is varied from 0 to its full scale, and then if the input is decreased from its full scale value to 0, the output varies. The output at the particular input while increasing and decreasing varies because of internal friction or hysteresis. Then next, figure shows or illustrates the output characteristics of an instrument that exhibits hysteresis. If the input measure quantity to the instrument is steadily increased from negative values, the output reading varies in the manner shown in curve A. So this curve A is shown here. This is curve A. Figure shows or illustrates the output characteristics of an instrument that exhibits hysteresis. If the input is measured quantity to the instrument is steadily increased from negative values. So shown by the curve A. Then next, if the input variable is then steadily decrease, this input variable is steadily decrease, then uh, the output varies in the manner shown in curve B. So this is a curve B, curve B, curve B. The non-coincidence between these loading and unloading curves is known as a hysteresis. The two quantities are defined: maximum input hysteresis and maximum output hysteresis. As shown in figure, hysteresis is most commonly found in instruments that contain springs such as a passive pressure gauge. Okay? So hysteresis we can also define if an instrument provides different readings for the same measured values depending on whether measurand is increase or decrease, then the output characteristics of this instrument is said to have an hysteresis. Next definition, dynamic characteristics. So till you have अब तक हमने जो भी characteristics mention किए हैं, static characteristics we have mentioned. Then next we have to mention dynamic characteristics. The instrument rarely respond to the instantaneous changes in the major variables. Their response is slow or sluggish due to mass, thermal capacitance, electrical capacitance, inductance, etc. Sometimes even the instrument has to wait for some time till the response occurs. These type of instruments are normally used for the measurement of quantities that are fluctuate with time. The behavior of such a system, whereas the input varies from instant to instant, the output also varies from instant to instant, is called as a dynamic response of the system. Hence, the dynamic behaviors of the system is also important. So, dynamic characteristics. Then, types of dynamic input. So, there are two types of dynamic input, either transient or steady state periodic. So transient response is defined as that part of response which goes to zero as the time becomes large. The steady state response is the response that has a definite periodic cycles. So in dynamic input, there are two types, transient and steady state periodic. So the variations in the input that are used practically to achieve dynamic behavior are step input. What is step input? The input is subjected to finite and instantaneous change is called as a step input. Then next is a ramp input. The input linearly changes with respect to time is called as a ramp input. Next is a parabolic input. The input varies to the square of a time. This represents constant acceleration. Then last is a sinusoidal input. The input changes in accordance with the sinusoidal function of a constant amplitude is called as a sinusoidal input. Then dynamic characteristics of measurement system are, these are the dynamic characteristics of the system: speed of response, fidelity, lag, and last is a dynamic error. So we will take one by one. So first is the speed of response. It is defined as rapidity with which an instrument responds to the changes in the measured quantity. Rapidity with which an instrument responds to the changes in the measured quantity is called as speed of response. It shows how active and fast the system is. Speed measuring instrument. So this is called as a speed response. Then next term is a fidelity. It is defined as the degree to which a measurement system is capable of faithfully reproducing the changes in input without any dynamic error. So you can, if you observe any technical specification of any equipment, mechatronics equipment, electronics equipment, all these measurement parameters are specified by that company. Means all important parameters in that fidelity is also mentioned. So it is defined as the degree to which a measurement system is capable of faithfully reproducing the changes in input without any dynamic error. And next is a lag. What is lag? Every system requires its own time to respond to the changes in input. This time is called as a lag. That is, if you give input and then that equipment takes some time to respond, the changes to the input is called as a lag. Word itself indicates. It is defined as a retardation or delay in the response of a system to the changes in the input. The lags are of two types. First is a retardation lag. As soon as there is a changes in the measured quantity, the measurement system begins to respond. Second, time delay. The response of the measurement system starts after a dead time once the input is applied. They cause dynamic errors. So this lag is also important. Means if we provide input or change the input, previous output is showing, or it will take some time to respond the input, is called as lag. Then next parameter, dynamic error. So what is dynamic error? It is the difference between true value of the quantity that is to be measured changing with time and the measured value if no static error is assumed. So what is dynamic error? Difference between the true value of the quantity. Means in some of the equipments standard values are represented but equipment is showing other value. It is called as it is a difference between true value of the quantity that is being to be measured changing with time and the measured value if no static error is assumed is called as a dynamic error. So in this lecture we have taken different levels of mechatronics, so different levels or evolution of mechatronics. So keep in mind words: primary level, secondary level, territory level, and fourth level. So primary basic components, secondary some additional part, that is a microprocessor based microelectronics is there in secondary level. In territory or third level or third and fourth level in some systems is mixed, that is some advances are added, that is either use of you can say IoTs or neural fuzzy logic, or you can also add image processing, advanced audio video processing in that system. So some advances if we add, it is called as a third level of mechatronics. Then we have taken a measurement characteristics, different measurement characteristics, other static characteristics or dynamic characteristics. In static characteristics we have taken different definitions: accuracy, precision, then hysteresis. Okay, so these definitions you have to keep in mind, and also linearity, the so n number of definitions. So keep in mind these definitions. Then next we have studied dynamic characteristics. So in dynamic characteristics we have seen the lag term, then the dynamic error. Okay, so previously we have all these terms we have studied in detail. So uh, keep in mind all these terms, and also solve in your or write down in your notebook, specifying the main important points, so you can recall all these terms in exam. Okay, so we'll stop here, and in the next lecture we'll take next topic to this mechatronics, that is some applications uh, specified in our syllabus. So we'll take in next lecture. Okay, thank you.